हाँ जी। देख, फर्स्ट इक्वेशन तो ऐसे आ जाएगा। हेलो।
बोल रहा है क्या तो कुछ?
हाँ, बी का सॉल्यूशन बताओ।
हाँ हाँ, बता बता।
अरे तो छोड़, मैं लास्ट में करता हूँ। तू कर ले, फिर
हाँ
अपन
हाँ।
लास्ट में डिस्कस करते हैं।
हाँ वो लाइव स्ट्रीम का लिंक भी
चलेगा।
भेज देना। हाँ ठीक है ठीक है।
कर रहा हूँ, मैं कर रहा हूँ। बता रहा है लाइव स्ट्रीम पे। मैं देखता हूँ।
हाँ आ रहा है।
हाँ, आ रहा, आ रहा।
ठीक है ठीक है। ये तो सबसे हो गया होगा, बट डिस्कस कर लेते हैं। ओके। तो ए में क्या दिया है? देयर आर टू फुटबॉल टीम्स with these names. We can just call them A and B. And uh, so in a football match, there are two halves, and in each half, in wait, in each half, none of the teams should score three consecutive goals. So we are given first half के goals by team A and second half के goals by uh, both the teams. We'll just call this X and Y because A and B is already used. Team X and Team Y, okay. So in the first half, the goal scored by them is A and B, and in the second half, it is C and D. Okay. So we are supposed to find if it is possible that there are no three consecutive goals in both the halves. For example, you can take this test case 1, 4, 1, 4, and 2 and 5. This is A, B, C, and D. So, is there a way to arrange these goals so that there are no three consecutive goals by a specific team? So, we can arrange it as B, V, A, and B. So, basically, whichever team has the lesser goal, we can accumulate it like this. For example, uh, if A equals 1, then at max, how many Bs can we accumulate? So we can accumulate 4 Bs like this. There are no three consecutive goals by any team. If A equals 2, we can accumulate it like this. B, B, A, B, B, A, and B, and B. So whichever team has the less number of goals, we can find that team and we can find what is the maximum number of goals that the second team can score. So in this case, it is 2 multiplied by, it is actually 2 plus 1 multiplied by 2. So it is basically the team which scored the less goals. Let's call it minimum, plus 1 multiplied by 2. This will be the at max score. That is the second team can score at max these number of goals, or else there will always exist a consecutive 3 times goals. Okay, so we can just check this. For example, this test case 19, 41, 30, and 50. So in this case, uh, these are the goals scored by the team in the first and the second half. In the first team X and Y, X and Y. So in the first half, Team X scored 19 goals and Team Y scored 41 goals. So the minimum goal scored is by Team X, which is 19. And according to that formula, which is 19 plus 1 into 2 equals 40. So this team Y has scored more goals than 40. So there will always exist a 3 times consecutive goal by Team Y in the first half. Therefore, the output should be no in this case. Now for the second half, what we can check is we can check the value of C minus A and D minus B, and we can do the same thing. Because in the first half itself, Team X has scored A goals and Team Y has scored B goals. So in this only in the second half, Team X has scored C minus A goals and Team Y has scored D minus B goals. So yeah, that's all I did in my code. So first I found the min element among A and B and the max element. And in case the max element is more than min element plus 1 times 2, which can also be written as this, then I just outputted no and returned. And I also did a C minus equals A, which is equivalent to C minus A and D minus B. And then I did the same thing with C and D. If it passes all of these, then I just output yes. Okay. Let's discuss B. So we are given a binary string S of length n and an integer k. Aquawave wants to construct a permutation P of length n so that for each of these values, wherever the binary string has the value 1, the following condition holds. Uh, this condition is that for each interval L comma R, wherever the length is at least k of this subarray for this interval, if it covers position I, then the maximum element should not be that I element. So we have to find such a permutation, or we have to determine if such a permutation does not exist. Okay, so we'll just take a test case for this to understand it more clearly. So in this case, we are given this binary string, and the limit for the sequence is 2. That is, the sequence should be at least of size 2. Okay. So can we construct a permutation by using this? So will 1, 2, 3, 4, 5 be valid here? Let's see. So basically, let's say for this one element, is this permutation satisfying for this element? So for this element, uh, at max, we can choose this subsequence, which has the maximum value of 2, or we can choose this, or this, or this, which will always have a maximum value not equal to 1 because there are elements greater than 1 in this subsequence, in this subarray. Okay, so it will satisfy for 1, but it won't satisfy for 2 because for 2 there is this subsequence where L equals 1 and R equals 2, and the maximum value for this subarray is 2. So therefore it won't satisfy for this 2 element, and we have to check for this element as well because its value is 1 in the string. Okay, so is there some other way to do this in this case? So one thing to notice is that for a subarray with size k, in this example, case size is 2. So for this, there will be one element here. Let's call it A and let's call this B. And there will always be one of these elements which is greater than the other element, right? Greater than or equal to, like B is greater than or equal to A, or A is greater than or equal to B. So for a subsequent subarray of this size, we will not be able to construct a permutation because we can take any value here like 1 comma 3. Uh, so for this element, it is the maximum in this subarray, right? 3 is the maximum in this subarray of size 2. So it is not possible whenever we are supposed to find, uh, like whenever consecutive one elements occur, we won't be able to find a subarray. For example, let's take one more example here. 1 0 0 0 1. So in this, and this is the same 5 and 2. In this case, we can construct a permutation because we don't have uh, subsequent 1 elements with size greater than or equal to 2. Because in this case, we can just put 1 here, we can put 2 here, we can put 3 here, we can put 5 here, and we can put 4 here. And this will satisfy because for each of the subarrays with size greater than equal to 2, these elements, we have to take into consideration the first and the fifth indexed elements. And for this element, 1. So we can produce these subarrays using 1 and this element. So all of these subarrays have an element which is greater than 1 in them. Therefore, we can satisfy this condition for 1. We can similarly satisfy it for 4 because 4 can have 5 with it because we need the minimum size to be 2 and here the maximum element is 5. Okay, so we can satisfy this. So what we are supposed to basically check here is that for this binary string, if there exists consecutive 1 elements more than k or equal to k times, then it is not possible, or else it is always possible. That's what my code does here. Sorry. हाँ हाँ वो हाँ हाँ मैं वही बता रहा हूँ. Okay. So I just checked if there exists a subsequent one-sized subarray with size greater than or equal to k, and if at all it exists, I just output no here, or else I output yes here. And yeah, we are also supposed to print the entire array for it. So the easiest way to do that would be yeah. So the easiest way to do that would be, let's say for this case, so we can put uh, wherever the string is 1, we can just put the minimum element from the permutation. So we can put 1 here, and we can put 2 here, and we can put 3, 4, and 5 here. So now, whenever we take a subarray of size 2, there will always be an element greater than the element which has the string value as 1. For example, this and this. So it will always satisfy for it. So that's what I did in my code. So current is my first permutation value, which is the lowest permutation one. And current plus plus. So current now becomes 2, 3, 4, 5, and wherever the string value is 1, I I keep the answer as current. Whenever it is 0, I again keep the answer as the next greater elements, and I keep doing current plus plus, and then I just output this. Okay. Any doubts till here? Hello.
No, no,
No,
no.
no.
Okay. Let's discuss C then. So we define that a block is an array where all elements in it are equal to the length of the array. For example, in this array, 3 occurs thrice. In this array, 1 occurs once. 4 occurs 4 times in this array. So these are defined as a block. This is not a block because 1 occurs 3 times. Here, 3 does not occur 3 times and 2 does not occur 2 times. Yeah. So an array is called neat if it can be obtained by the concatenation of an arbitrary number of blocks. So basically, let's say neat array can be like 1, 2, 2, because here 1 occurs one time continuously and 2 occurs twice. Uh, However, this is not a neat array because here 2 does not occur twice consecutively, but 1 does, but 2 does not. So this is not a neat array. So we are supposed to find the longest neat subsequence in the given array. Okay, let's take a simple example as this. So we are given this array and we are supposed to find a subsequence which would satisfy the neat array condition. So basically we are supposed to form a new array out of this. Okay. So here what could be the arrays that we can form? So we can form this, we can append this to the array. The subsequence can go on as like this. 3 occurs thrice, so we can also take this with us.
Okay.
And then we can also take 1 here, because 1 occurs 1 times consecutively. And the size is 5. That's what we output here. Okay. Let's take this example.
Aigo. Sabi, Aigo. Sir, मैं दाबतो आहे तो.
घट्ट आहे ती माझी.
Can you mute, please?
चला, टाटा. घेऊन दे.
Okay, so hold up. Yeah. So for this array, we could select 2 here and then the next 2 here. Or, but in this process, we are skipping these 3 elements. But it could be an option. So first, one thing we can do is we can select these 2 twos here. Now we can't select 3 here because there are no further elements, but we can select this one and this one because they occur once, and 5 does not occur 5 times after this element. Another option is that we can, yeah, so we can take this, we will not append 2 here, and we will choose to select these 3 elements, and then we can choose 1 and 1. We cannot append 5 here, either can we append 7. So 1 and 1, this will be our subsequence, and this is the greatest value of the subsequence that we can form, which is 5. Okay. So one thing we can notice in this problem is that we only have 2 options. We can either pick an element or we can not pick it, which gives us the intuition to perform dynamic programming on this. So I'll just draw this array again. Yeah. So how would the dynamic programming work? Let's say we pick this element here. So till this element, what is the size of the wait? till this element, what is the maximum subsequence that we can form? So even if we happen to append 2 to our subsequence, the value would still be 0 because we need at least two twos so that the value becomes 2. So till this point, the value will be 0. Okay. Till this point as well, the value will be 0 because we cannot append 3 just once. We will have to append it thrice at least. Then till this point, the value will again be 0. Till this point, yeah. So here we can append 1 because 1 should occur only once for it to be called, what is the word? Block. Yeah, for it to be called block. So till here, the maximum subsequence that we can form is of size 1. Till here, now, till here, we need to somehow track count of the previous two in order to know that there already exists 1, 2. So till here, the maximum size can be 2. Till here, the maximum size can, since there already exists two threes before, the maximum size can be 3. Till here, the maximum size will remain to be 3 because there is no previous 5 element. Till here, the maximum size will be 4. Here it will be 5, and here it will be 5. And we just output this element. So now, how exactly do we calculate this previous element and how do we track this element? So one thing to notice is that all the elements are lesser than or equal to n. So we can just store all of the positions of 2. For example, let's say we can store all of the positions of each of these elements as we keep visiting them. So in the first step, what happens is uh, 2 has the position 1. In the next step, what happens is 3 has the position 3 occurs at position 2, and simultaneously we can just keep updating our dp of I as max of dp of I minus 1. That is, we do not pick this specific element at index I, or we pick it. So what would be the formula here? So the formula here would be, let's take this example here. Till here, what would happen? So 3 would have the position 2 as well as 3, and 1 would have the position 4. And 2 would have 1 as well as 5. Okay. So now whenever we encounter this element, for example, what we can track is the position of this element, which is 1. We can also make this 1 based indexing, and we can just put 0 here at the 0th position. Yeah. So what we can find is if we are supposed to include these two elements in our subsequence, what would be the maximum value? So it would be dp of I minus 1, which is this. That is, we do not pick this element. And if we do happen to pick it, we will have this value, which is the previous of the previously occurring 2. So basically, it is the current size of this array minus 2, since the element is 2, minus 1, this value, which is 0. So 0 plus, now 2 occurs twice, therefore 2. So here it will get upgraded to 2. Similarly, in this case, the size of 3 becomes 3. Size of this array becomes 3. It has the 3 elemented positions 2, 3, as well as 4, 5, 6. Yeah, 6. So we can track the previous element of this, which is 1, 1th position. So at the 1th position, the value is 0. So dp of this position, which is 1, 2, 3, 4, 5, 6, will be max of dp of 5, comma, this position, which is currently, wait, sorry, this position, which is currently 1, and it has the value 0. So the value at that position plus the value right now, since we have 3 elements, we can add 3. Okay. Similarly, dp of 7 will remain 6 because 5 does not have 4 elements before it. Now for 1, the current position of 1 would be, currently 1 would have just this 4 position. So it would be max of dp of this element plus 1 or this. So basically it will be 1, 2, 3, 4, 5, 6, 7, 8. Yeah, dp of 8 would be max of dp of 7, comma, the previously occurring element for 1, which is this position, and at this position we have value 3, plus if we include this one, we will have the value 1 more, because 1 needs only one element for it to be called a block. So it would be 3 plus 1, which is 4, and this is 3, so it will be updated to 4. So we keep doing this and we just output dp of n, dp of the last element. Okay, so I just took the input here. This is redundant. I was trying a different approach here. Uh, yeah, so we define a vector of previous. Previous is basically this entire vector of vectors where we are storing the position of each element. And yeah, to make it one based indexing, I just did this. And dp of 0, if v of I equals 1, then dp of 0 will always be 1, or else it will be 0, irrespective of which element it is. I initialize that dp like that. Then I just did this dp of I equals max of dp of I minus 1, comma this. Temp is basically uh, if the previous element is greater than 0, then I put it as dp of previous, comma last position minus 1, which is this position that I was talking about. For example, for 3, whenever we encounter this, then we just find this position and we find the value before it, which is at position 1, which is 0 here. So that's what it is. Or else temp is just 0. Temp is 0 if, like, if I access out of bound elements, I just put it as 0 here, and dp of I equals max of this, comma this, or else dp of I equals dp of I minus 1. Okay, and I just outputted dp of n minus 1, since it is my dp is 0 based indexing. That's it. Any doubts, Nancy? Cool. Okay, Ari, can you explain your D
So,
approach?
is the screen visible?
Hmm. Yeah, it's visible.
Yeah, so basically, uh, assume that first of all, we need to know the signs of the element. operation, right? So first of all, let's say that take maximum x, say that my maximum x is somewhere over here, and say that my maximum y is somewhere over here. So if they intersect over here, okay, so if they intersect over here and my initial given x dash and y dash, if assuming that if they are more than this point, that is x dash and y dash, if I put it somewhere over here, that is outside of the boundary. So what will be the minimum distance? That is the Manhattan distance. It will be this simply, right? From the outermost point, that is the maximum x point and the maximum y point, right? So can we bring the x point and y point beyond this boundary? We can, right? We can just add infinities to both my x dash plus infinity, comma y dash plus infinity. So this will just bring this point out of the boundary of x, which is my minimum y point over here maybe, and maximum x point over here. So the Manhattan distance will simply be this. Okay. Now assume that there are many points over here like this, and uh, now we know that what will be the Manhattan distance from these points to these points. Okay, wait, let me draw it more neatly. So if we call the boundary as this, that is, and we know that boundary will be 1e9 to comma 1e9. Uh, I am pushing my x point, the original point on which the robot was outside of the boundary. That is x dash and y dash, and say that I have many points over here. Okay, so the Manhattan distance will simply be x dash plus infinity plus y dash plus infinity minus px and minus py. Px and py is one of the given points. Uh, as we are given n points, px and py is one of those points, right? So what we can say that the Manhattan distance is simply uh, 2 times infinity minus px minus py plus x dash, which is the initial point, plus y dash, which is the initial y point, is equal to d, which the tester will give us. So what we get from this? 2 times infinity minus px plus py. Px plus py is one of the given points, okay? Minus x dash plus y dash, which is the initial point, is equal to d. So let me say this is equation 1, all right? And what we know, because the tester minimizes the distance from the observed point, from the given query point, sorry, from the current, from wherever the initial point is currently. So this will be maximized, right? This has to be maximized, and we can compute maximum px plus py initially. Now, if we compute this initially, then I simply get x plus y dash is equal to d by just subtracting 2 times infinity from this equation and just adding maximum px plus py. Uh, this will be right? So this is equation one, and from this equation, I can just get this equation, right? Because we know what is 2 times infinity, and we know what is maximum px plus py. This is equation one. So now, to solve this equation, I just need another x dash minus y dash equal to d, right? So how do I get this? So for this, what do I do is I keep two, so I keep x dash plus infinity as it is. What I do is I just say that the y point will be y minus infinity. Okay. So now what will be the Manhattan distance? Because this point is minimum, the Manhattan distance will be this will be simply x dash plus infinity minus px plus, because obviously this will be maximum x, and I'll have to subtract any px that is from my already given points, and obviously this will be the minimum y, so obviously I will subtract py from this y minus infinity, right, which is equal to d. D will be given by the hashtag code. So this is just x plus infinity minus px uh, plus py minus y plus infinity equal to d, which is 2 times infinity plus x dash minus y dash minus px plus py, which is equal to d. This can be written as 2 times infinity minus px minus py plus x dash minus y dash. Here x dash and y dash are my initial point on which the robot was equal to d. So again, this equation, I have to maximize this because I'll get the minimum Manhattan distance. Okay, so if I can simply pre-compute what is the maximum of this, and so I'll just, and if I just add the maximum of px minus py to this, and just subtract 2 times infinity from this equation, I'll just get x dash minus y dash equal to d, and this is my second equation. So this was my first equation. Sorry, x plus y. This was my first equation, and this was my second equation. So we can simply say 2x dash is simply equal to d1 plus d2. This is d2, and this is d1. And so x dash will be simply equal to d1 plus d2 by 2. And similarly, y will be equal to x dash minus will be d1 minus x dash. So this gives me my initial x and y. Yeah. So coming on to the code part, I'm just taking the input. I am just pre-computing for my equation one, for my equation two. This is the query. I just, so now to get this x point and y point out of the boundary, I need to add infinity twice, right? Because say that 1e9 is my 1e9 and 1e9 are points on boundary. I need to add infinity twice to make it at least 2e9. So that is what I have done. I've added 2 times to x. I've added 2 times to y. So total I've added 4 times, which I subtract from d, which is the input which the tester gives me. This is x plus y. This is simply x plus y, and this is simply x minus y, and we can simply solve this equation like this. Okay. Any queries on this? Hello.
Is the stream on, Sachin? On, eh?
Yeah, so that was all for D.
Hmm.